Hey everyone, this is Craig Scott, founder and CEO of Fuuz, and I am recording a Fuuz Unplugged podcast. I wanted to go over a few things. I've had a ton of folks reaching out to me with just general questions on a few things, specifically related to AI and our use of AI in and around the Fuuz platform. If you've followed us on LinkedIn at all, you know that we posted our Claude skills out there on Git for you. If you're looking for those, just go to GitHub, look for the Fuse Industrial Intelligence Platform, and you'll see the repo there for the skills. They're also available in our knowledge base at support.fuse.com. And I wanted to touch on that and give you a little bit of background on what those are going to enable you to be able to do. And also talk about a little bit of how we utilize this through the ProveIt conference 2026 in Dallas. So if you were not at the conference, um, why? First of all, but secondly, go check out our LinkedIn page. You'll see a ton of information and posts from the week. There's a ton of information being shared from numerous different vendors. We focused on solving problems in two of the virtual factories. And I'll show you what a virtual factory looks like for those of you that aren't familiar with that. I know I work with kind of both ends of the manufacturing spectrum from IT to OT. Most of the folks I know working in IT have never heard of a unified namespace or MQTT or message brokers or a lot of these types of things. And most of the folks I know in the OT side really don't think too much about, not to say they don't, but it's not top of mind with things like security, governance, API protocols and things that we use on the IT side. So we kind of brought all of this together for our ProveIt presentation. So at ProveIt, it's about a week long. Um, we arrived on Sunday, got the booth put together. We had our presentation Thursday morning, immediately following SESME, where they presented information on the alpha release of the i3x API, which is a GraphQL based API that the intention, essentially, long story short, is to keep it a very open and agnostic interface and exchange of data between enterprise systems. So anybody that knows Fuse knows that that's been our mantra for the past 10 years. So we embraced that. We went on after SESME and just before the fireside chat. So in our presentation, we covered primarily Enterprise B. So I'll show you what I'm talking about here. I'm going to bring up an MQTT Explorer. I'm currently connected to the virtual factory for ProveIt. So every year when they do this show, they set up a virtual factory. And a virtual factory is exactly what it sounds like. It's virtual. We have Enterprise A, B, and C. If I expand Enterprise B, I can see that I have Site 1, Site 2, and Site 3. The sites are very similar. It's a bottling, liquid filling operation. So they're making different types of sodas and things like that. So it's a mixed mode manufacturing. There's batch, process, and discrete sort of happening, all in line here. We have Enterprise A, which was the enterprise that was available in 2025. That one is primarily discrete, where they're producing the glass bottles that then flow to Enterprise B. Enterprise C we'll take a quick look at here because this one's totally different. Enterprise C was essentially a life sciences demonstration. So we have bioreactors and different production line equipment that's processing a particular strain of a protein. So that's very different. Mostly raw data, some telemetry information. There's some batch information, but that one really took a lot more work to try to understand and uncover what exactly was going on there than the other facilities. So what you're seeing here is an MQTT Explorer, and the information, the way it's semantically structured here, essentially represents the idea and the goal behind a unified namespace. So you have your ISA 95 standard enterprise structure. So enterprise, site, line, area, cell, work unit type hierarchy. You can see a lot of different vendors listed in here. So we see Ableera, that's a partner of ours, Software Toolbox, Dynix. Here you have the Fuuz. So what we had to do is both consume information from the virtual factory, but we also had to publish back into it to show the openness of the whole idea behind this virtual factory and behind unified namespace is that it provides real time state of the enterprise. What you won't find in here anywhere is any type of historical data. You cannot query the UNS. You can't ask it anything. You can't interrogate it. That's purely pub sub. So if you're not subscribing to what's called a topic, so if we drill down and we look at our Enterprise B, we structured this as Enterprise B, Site 1. We had finished goods storage where we have trucks that are taking product out to our customer. There are shelves. Each of these is a location in the warehouse where we can track the current state of each of those locations. So imagine every time a material handler scans something on a handheld, it's triggering a message that gets published into the UNS. So you might have another system like an ERP, theoretically, that is subscribing to the shelves topic, and anytime something's updated in there, those messages then can get picked up by the ERP system and create a transaction in that system. That's the general idea at a high level, so that you're not necessarily dealing with the traditional SOAP, XML, API, FTP type stuff back and forth. So for those of you in IT, that's sort of the idea. For anybody that's not that familiar with Fuuz, the back end of Fuuz is essentially what you see here on my screen. So we are an event-driven architecture, and by definition, the UNS is an event-driven model. So every time something changes in Fuuz, there is a message broker inside Fuuz, and those messages are being published to it. Other things within Fuuz can subscribe then to those messages. We call them data changes, right? So same type of thing, but that might be an operator control panel on the shop floor. Someone records production or scrap. It could be a material handler receiving material, putting goods in a warehouse. It could be someone in finance posting a journal entry. It could be a salesperson working in your CRM that enters a new sales order or creates a new customer. All of those things that funnel through Fuuz as your centralized hub creates these events, which makes all of your integrations work. So that's one of the things all of our customers typically come back and say is, we're doing the integrations with Fuuz was super easy and they just work. And the reason for that is because of the architecture that we've built behind the scenes. So you can see that as I flip through these different shelves, different locations. So S4B2 is an aisle rack location in the warehouse for this fictitious virtual facility. And then we can drill through. We have vehicles. So we created were two AGVs that essentially take material from the end of the production line and then move that to the warehouse. And I'll show you the user interface that we built for that. We did some machine learning on Enterprise C, so the biomanufacturing facility. So we drill down biologics, manufacturing, Dallas, Fort Worth, production line 1. We have a bioreactor bay. We have one bioreactor there, sub 250. And then within there, we have all of the data that we were calculating. So this is all machine learned data in Fuuz. So we're taking the raw information from up here that's being created by the virtual factory. We're ingesting that in Fuuz in real time. We're storing the raw data. So we created a historian in Fuuz using our data modeling. And then from there, I built 3 web flows that take that data and do some processing on it. So there's the first flow that takes the raw data, generates some insights on that data. So it analyzes some trends. And then based on what trends it finds, it stores those values in another table and so on and so forth. So it is truly doing some machine learning as these values are constantly learning and being manipulated, and we're seeing trends and z-score values that are being updated as we collect more and more data. So what we built around that was a batch prediction. So one of the challenges in these bio reactors and in these factories in general is that you have to do a lot of monitoring of the batch to determine when the batch is going to be ready for harvesting. So you have to do samples, you have to do a lot of different things manually, which is time consuming, right? And it's just difficult to run an operation that way. So what we did was we found some correlation pairs between different events on the machine. Take half a dozen different sensors, you monitor those for a period of time, you find correlations between those sensors, and over time, as you have some batches that complete through a manual process, you're able to look at all of the different trends and anomalies that occurred, from the start to the end of the batch. So in future batches, you have an ability to predict when they will be finished. So that's what we built, all with data flows and Fuuz. And when I say we, I mean the team of two of us, essentially Claude and myself. So, down here we're creating some cross enterprise alarms. So one of the things we also wanted to demonstrate was Fuuz as being a enterprise class system. So we didn't just build one plant in a silo. We took all of these three enterprises plus three of our own, which we see down here. We have, Houston with some machines, some lines. We're tracking the state. We have Detroit with a machining, a couple different horizontal machining centers, C1, C2. We have a stamping line. So in Fuuz, we have our own virtual factory running, which is again a data flow. So these are all things you can do with data flows in Fuuz. So we have a data flow that's creating data like uptime, downtime events. It's publishing those to the Fuuz UNS, and then we're consuming those events and then publishing them back out to the public UNS here that we used for the ProveIt demonstration. So this is basically UNS, Unified Namespace, real time, last known state that your enterprise was in. As I said, this is not queryable. So one of the things that is problematic with UNS is that if I close this and I open my MQTT Explorer up again, I reconnect, I'm getting all new messages. So whatever messages were there a few seconds ago are completely gone. And anything that happened between closing it and reopening it, at least in terms of the visual nature that we're looking at here, completely lost forever, right? If I don't have a piece of software subscribing to those things, I can't get them back. In Fuuz, however, we've done a few things to address this. So if you're using Fuuz UNS, because it's all data change driven and it's all tightly coupled to our data modeling, all of those data changes are persisted in the database. So you can query history for any topic in the Fuuz UNS, which is extremely important. So not only can you query it, you can query a lot of systems, but we built a GraphQL layer over top of that. So it's extremely flexible and it says me I3X compliant. Very easy to formulate those payloads and create flows that'll exchange the data very easily. So that's all for the commercial. I wanted to show you what the UNS looks like for those of you that don't know. Right. So we talked about the material handlers and we built these AGVs to move materials around. We talked about Enterprise B and Enterprise C being very, very different. And I'll show you a little bit about what we built. I did mention that I use Claude. We've published our skills. Those skills have been generated over the past couple of months, just utilizing the tool. And if you guys have used UI to try to do or AI to try to do anything, you understand that oftentimes it gives you an incorrect result. So I think it's much like a child or a pet. It doesn't give you the behavior that you're looking for. You need to correct the behavior. And over time, as you correct the behavior, it does get better and better and better. So that's what we've been doing internally here at Fuuz. And over time of correcting that behavior, what we've done is we've captured all of those corrections into what we call skills. So now you can implement those skills into Claude. So if you have an account, you can go to like your organization settings, and in organization settings, you should be able to then navigate to your skills. And in skills, you can click the add button, you can import those, right? So you can go to our GitHub, You can download those, extract them, import them, and you should be good to go. Are they perfect? No, absolutely not. They're going to continue to be refined and matured, but for the most part, what we're seeing is that they do get better, and you can continue to iterate over time. And in doing so, it really makes building things in Fuse so much faster. It was already quite fast historically, but now it's even faster. So I'm going to show you a few of the things that I built and touch on a few points because, again, I felt a little bit bad that the team did so much work. We didn't get to show everything off. So, as far as the stage presentation, it went extremely well. I thought we really didn't talk much about the connect collect piece because everybody does that. We do it very well with the Fuse Gateway. So the Fuse Gateway has MQTT broker and client. We easily connected to the UNS and started subscribing to all of those topics that we were just looking at and publishing those into the Fuse UNS. So once we got them there, then it was just a matter of storing it into our schema and trying to find some patterns and things that we could build a solution around. So I have a ton of these Claude windows that we've gone back and forth with. This happens to be the one where I wanted to build a machine learning algorithm, but using just pure vanilla JavaScript. So I need to do some Z-score analysis on all of the raw tag data that we were collecting. And I utilized Claude to help me build out the 3 or 4 different flows that we ended up with. And the data models, not so much. I just built those because it's very fast and simple to build data models in Fuse. What I'll tell you is that if you don't know what the end result is supposed to be, you should probably not be building apps. So I believe that the AI is really good at helping do some of the heavy lifting. Instead of sitting here scratching your head for hours or days on how to even get started or how do these different functions work, right, and doing all of that research, it does it in minutes. But you have to be really, really good at evaluating the output. So if you don't know what the output should look like, um, in all likelihood, skills or no skills, you're not going to end up with a very good application. So just take that for what it is. Learn your domain. Be really good at your domain. It's a great enabler, but you have to pay attention. You have to test. You have to validate. Ultimately, it's an assistance. It's not a replacement for anybody. So we built this alarms dashboard. This alarm dashboard is based on some master data that we set up in Fuse. So I'm going to expand this so you can see it a little easier. So the alarms dashboard, you can see we have 88,654 active alarms. I've acknowledged 16. I've cleared 33 in the last 30 days. We're averaging 123 alarms per hour over the last 30 days. And the total number of alarms generated in the last month is 88,703. So the math all works. That's fine. We have 3 tables. I've got the unacknowledged, which are the new alarms. We have the acknowledged, and then we have the cleared alarms. Just for the last 24 hours, the top 10 cleared alarms. This could be anything, though. These are just filters that I happen to apply. So this dashboard, 100% generated by Claude, was quite simple to do, just a little bit of back and forth. So my workflow is I've kind of got that fine tuned at this point. If I go into my app designer and I can show you guys a little bit under the hood of what this looks like. So I'm going to look for my alarms dashboard, which is right here. I'm going to open that up, get rid of that. So this is the alarms dashboard. This is what it looks like in the designer. And I can go to preview just to kind of get rid of some of the noise. So all of the noise is really just all the different containers and layout elements and everything. So this just gives you kind of a cleaner perspective of what it looks like. It looks just like the dashboard we were just taking a peek at, right? So we can run this, we can test it. So when I say you have to test it, like this is exactly how we go about testing. So from my application designer, I can hit this guy here. It'll pop it out in another tab. where now I've got a rendered version of the screen with all the queries and transfers, everything is running. So if I go up here, throw this into developer mode, I'm gonna get rid of the menu just for some extra space, and I refresh. Developer mode is really helpful because that's what gives us all of the behind the scenes, what's going on this page. So if I acknowledge an alarm, you'll see everything that's happening, right? So all of these transformations that are happening, the queries that are running, everything that's updating this dashboard, I can see in this developer console. I can turn that on and off here, um, and then I can navigate through. So one of the things I found that's really interesting is I essentially built a mini UNS. So we have the back end UNS. We have a lot of UNSs going on. So we have the virtual UNS, we have the Fuuz back end UNS, and I kind of came up with this concept that I wanted to have a little mini UNS for my user interface, right? So at the screen level, if I go through components, so these are all the different screen components, right? So every card, every text field, everything you see visually is a component. There's also this one at the bottom, screen. And within screen, I set context. So my screen context is very interesting because it is essentially all of the data in real time as it's being updated by the virtual factory, by the Fuse factory. All of these data points are being updated. So these UI components are just subscribing to these values. And I was able to teach Claude how to do this. And by doing so, that's now part of our skills. But by doing so, it greatly reduced not just the complexity of the UI, but also just the nature of how we interact with it from a designer standpoint. So we can go in here. We'll take a look at another section, see what we've got. So you can see that we've got the active count, the acknowledged, the cleared total. Now you don't see the tables because I left the tables as a table query, which is native behavior infused. So if I select this table in the application designer and go to properties, what we're going to see if I scroll down here is that this is just using our existing API. It's querying the alarm data model. I have it set to auto load. So when the page loads, it's going to automatically run this query, get all the data, and load it into this table component, right? This table element. And I have this transform that is setting some filters, right? So Claude wrote all of this just based on my instruction. I didn't have to do any of this. I do know how to do it. But if you're not familiar with JSON transforms, then your LLM is really good with it. And then you can still come in and modify and tweak all of these elements based on whatever your particular use cases are. So it was quite simple to do. Some of the cool things that we came up with in order to drive this kind of mini user interface UNS was we utilize the page load functions. So within Fuse, when you build a screen, I can do a few things. I can associate a flow, and a flow is like a data operations pipeline that can be backend or client side. And I can load that flow immediately when the page runs. And I have full access to everything within state of that user interface. I know who the user is, the date, time. I know which environment or which plant they're in. And I can pass all of those in as parameters to that flow to go run queries, execute functions. And I can also return data to the screen and I can persist it in that screen context area that I just showed you a second ago. I can also take the caveman approach, which I did here, and just write a JSON out a script that just executes when the page loads. So when this page loads, I set the time using the moment function and I figure out, okay, what was 30 days ago? So you remember all of the KPI cards were essentially the last 30 days. And then I'm running a query to get all of those. I'm doing an aggregation. So I'm counting the alarms based on their alarm state. So this is just a standard GraphQL query. In Fuse, we've added this inline aggregation capability. So that's really nice. It saves a ton of coding. And it's very simple. Pretty short little script, but this is doing all of the heavy lifting. And it's at the very end, it's storing everything that it's done previously in that screen context. So screen.function.setContext in brackets. I have my declarative here, which are all of these items that you saw before. So that's essentially the construct of the screen. Now, Claude output this a couple different ways. So depending on whether you're a Claude desktop or Claude Code user, there's going to be a couple different ways to approach this. So I've used both. I can say I'm shifting more towards utilizing Claude Code for doing most things, just because I really prefer the way that it works with a local directory. It builds the files, updates the files. So you run out of context pretty quickly with Claude Desktop, having to constantly feed things back to it. I find with code, I can iterate quite a bit more and quicker without having to move on to a new conversation. So what we'll see here is we built a mean time to repair and a mean time between failure capability in this application all around Enterprise B and Enterprise C. We utilized Claude to help us build out the flows that are calculating all of the alarm values based on states and durations and how long it took to move from a down state to a production state and things like that. So you can see that we included this in all of this. So this was quite a bit of iteration back and forth, but you can see the type of documents it creates. So different folks have taken different approaches. Mine personally is because I like having a little bit more control, is I will actually frame out the data flow in Fuuz. So I know the steps typically that need to happen in order to process something. I like to frame that out, but then utilize Claude to just do the heavy lift. So in this particular example, I needed an ISO 22400 compliant work center state change generator, right? So that doesn't really make sense, but the reason was I wanted my OEE calculations and other KPIs to be compliant with the standard. So it wrote this JavaScript function, which I was able to just copy and paste. So I copy and paste that into a JavaScript node in a Fuuz flow. And upstream from this, it helped me out. It wrote a lot of the queries so that it would get the proper data to pass in. This here is the sample JSONata to format everything that we're passing into the JavaScript. So there's a query node getting data. I'm transforming that using JSONata and then passing that into JavaScript and finally out and storing that in context on a screen for the dashboards. So over here, it'll actually walk you through each of the steps. Like, how are we going to, it helped to architect the solution. Of course, I kind of held its hand and corrected it in some areas where it was kind of going a little wild. Sometimes it will generate the Rube Goldberg of solutions when it really doesn't need to. Or in our particular case with Fuuz, because it may not be entirely up to speed on all of the custom bindings that we've created for JSONata and JavaScript, that it might do something in 5 or 10 lines of code that I know I can do with a single binding. So just correcting it with things like that, that a new user to the platform may not necessarily understand. But again, that's the value in these skills that we're helping create, is taking the learning curve for somebody who's brand new down from, maybe a couple of weeks from being a pro to maybe minutes or hours in some cases. So we can copy, we can download, we can do all of those things. I can also show you, for example, that alarms dashboard that we've worked on. Claude just generated the JSON file for that, which looks like this. This is the actual JSON file for the screen itself. So after it generates that file, I go to my application designer, click screen, blank screen, go to file, import, and then I can select from my downloads folder my alarms dashboard. When I import that, boom, my alarms dashboard. Now I can save this. I can run it, I can do the developer console, I can debug it, I can make sure that everything looks good. So if we click through this, everything looks exactly like the one I just showed you. I noticed that like this one, for example, though, was missing the data model, right? So that's an error. Clearly, this needs to be the alarm data model, actually in a different tenant, which kind of makes sense. So, uh, just for those of you, on a live demo. So this was in factory C, which has an alarms data model. This, however, I'm in factory B, which is warehouse management, does not have an alarms data model. So that's where you get into situations like that. But it also highlights a very special thing about Fuuz is that I can operate my facilities very differently. So they don't have to be identical cookie cutters. We have that flexibility. But if I needed an alarms data model in factory B, it'd be simple enough for me to import it or link data even to the other data model in factory C. So moving on from this, there's a couple things I wanted to just cover when it comes to screens and data models, right? So if I go to screens, one of the things I noticed about iterating, especially when it comes to screens in Fuuz and with AI, is that you can import a screen once into Fuuz and you can save it and you can give it a name, and that's going to create version one. And then from there, typically you're going to want to use the built in screen designer in Fuuz to make your minimal tweaks. So ideally, you'll get an 80 to 85% complete screen out of AI. And then you might spend another hour really just kind of fine tuning it in Fuuz, getting it exactly how you want it. There's another approach you can take if you're not comfortable with that, which is you can continue to iterate and iterate and iterate with AI. Sometimes I find that actually takes longer, but whatever. You can also go to the screens page, find the screen, go to versions, and if you select a version, there's a couple things you can do. So if you need to scrap a version because AI generated some garbage, you can totally do that. You can select it, you can come in and you can delete that version. This one's already been deployed, so I would have to deploy a new version that I could delete the old one. But also, this is what I wanted to get to, this design area. So this is the same JSON that we have right here, right? So what I can do is, because I had mentioned I can only import the screen once currently, and that's something we're working on. But if I need to override that, I just go to this screen version page, take my new JSON that Claude or whatever LLM generated for me, copy that, paste that in here, and give it a save, and then I can go through the same process. So there's multiple ways to getting this stuff in here. I personally like this copy and paste kind of workflow because it keeps me in the loop. What I am really not sure of yet is just letting Claude make these changes directly for me in Fuuz. We will get there, likely through the MCP tools. We're in the process of building out some extensive library of pre-built MCP tools, which will have security and governance on them, which is a big issue with MCP in general right now. But those tools will be forthcoming so that you could do a slightly more autonomous workflow, I guess, between your LLM and Fuuz. And then you can also use the Fuuz data flow tools to pass data out to your LLM as well. Just use the HTTP connector, use the Claude or ChatGPT API. We already have a ChatGPT API built in here. So if I go to my application designer, we can take a look at that real quickly. I'm going to go ahead and create a new data flow, not data model, create a new data flow and say, put it in the backend flow, be an integration. And then we can go look at all of the integration nodes we have. We should have a OpenAI or ChatGPT in here. So yeah, matter of fact, right here. So we have that one that's pre-built, but these are just REST APIs. So you can use the HTTP connector to connect to any REST API. Just set up a connection. That's going to be the endpoint URL and your credentials, and then set up your method, right? So get, put, post, delete. So you'll probably want to post messages off to whatever LLM you want. You'll get the responses back. So this could be anything like logs that are generated in Fuse from testing your apps, or even use these in an application. So if you wanted to, insert some type of agentic workflow with your MES or WMS, you absolutely could do that just using a couple data flow nodes. So let's take a look now at what it created for my ML. So I think I have one called detection. Yep. So this is my telemetry machine learning detection flow. So on ingest of raw machine data coming from Enterprise C from the UNS, here's my data change node. So I'm subscribing to the internal Fuse UNS via the data change node. When something is created there, so when I get a brand new raw value coming in from the PLC, that's triggering this flow. So this flow then, and part of that is I get a payload with it because I'm already subscribing to the internal, Fuse UNS. So if we do a capture here, we should actually see some data come in real time. So this will actually listen on this topic. There we go. So we got a whole slew of data. This is literally live streaming in to our UNS right now. So I can open this payload up and I can see here's the value. So for everything in our UNS, you're getting the before and after value. Before is null because I'm only listening on the create operation. So if I was listening on the update or delete, there would probably be some before data and after data, but there's not in this case. So here I can see the ID of the transaction, the value. It's not been aggregated yet. So this is the OPCUA good quality 192. I've got my timestamp of when it was recorded. I have my data point ID. So this links out to master data that we have in Fuse that's going to give us the engineering unit of measure and which asset it belongs to, which work center it belongs to. And then we can use that in our flow. So if we walk through this flow real quickly, I'm setting that. So that's my trigger, right? This is my value after. I'm setting that in context for the flow so that it's sort of like a cache, like an in process memory, so I can access it later in the flow. And then the very first thing I'm doing is I'm getting all of the context for that data point, right? There wasn't a lot in that trigger payload, but what I can do is take the data point ID that came in from the data change, and then I can execute this GraphQL query. In this GraphQL query, we are getting the data point. I'm getting the ID, the code. I'm getting the asset that it belongs to, the line, the cell, data type, frequency, the upper lower limits, if it's critical or not, what's my deadband, my set point, and is there an alarm enabled, and so on. So now I'm getting all that data back. I'm merging that into my existing context. I set up a mutex lock because these data changes are coming in fast and furious. As you saw, I got, only a list of about 20 when I listened, but these are coming in at a rate of, I think 250 a second. So there's a lot. And even for the same data point, I might be getting multiple successive reads off of the sensor. And by putting this mutex lock in here, what it allows me to do is catch. So for a single data point ID that I have in state, that's going to basically put a block. So as I process one data point through the flow, if that same data point comes in again, it's going to wait. It's going to pause. It's going to wait until I query my existing baseline, which is my machine learning values, right? So on the very first ingestion, there are no baseline values for a data point. When it's a brand new sensor and I've never recorded it before, this is just going to come back as an empty array. But as this runs over time, that baseline continues to get updated and updated. So it's having the min and max observed, the last value when it was recorded, my alpha, my trend slope, intercept. This is the brain for the machine learning algorithm. Every time that data point comes in with a new value, these values get queried from the table as they are for that data point, merge that into context. Then I go and I query the last 2000 raw readings for the tag. So I'm getting the memory. I'm also then going back to my raw data. I'm getting the last 2000. So I'm capturing all of these trends. I'm verifying that my memory makes sense based on the trends coming in. And then this is that JavaScript that Claude wrote for us. So as you can see, this runs through a number of things, and then we're merging some of the output into context too. So there's a route. What's my insight? So am I trending up? Am I trending down? Am I trending flat? And then the updated baseline data. So I update my baseline and then I release the lock. Once that lock is released, that same data point, next value can now come through. And that's kind of how it keeps iterating over that process. If I have insights, they go up here. I create those ML insight records. Otherwise, I'm done. So this flow just looks to see if it needs to update the baseline, and it does. And if there's an insight that it captured, it creates that as well. If I go back to my data change node and open up debug, I have these, right? So we looked at this before, and I can go ahead and walk this thing through. So if I get rid of this, we can open this up a little bit and it won't hurt anything. I'll select this, go to debug, and we'll walk that guy through. And you'll see as it steps through the entire program, and it got all the way to the end and it's done. So I can go to here, and if we want to look and see what happened, it's actually over here on the right hand side of my console. So it went through data changes, and we'll blow this up a little bit. It went through data changes. Remember, set context. I queried the data point. So here's what do we get for the data point? So we got the asset is a sub 250. Here's the sensor FCV 250 SP%. And you can see that I am supposed to historize this value, which means I'm going to be storing the raw value in the historian. My frequency is every 10 seconds. So that's milliseconds. My lower warning 0. It's not a critical feature. My set point 70, upper limit's 100, right? So I'm getting all the context of that sensor, and then I pass that through the rest of the flow. I queried for the existing baseline. So that's my telemetry raw baseline table that I created. So here's the values that are already in the table for that specific data point. So I'm pulling all of that in, merge that into context. Then I'm going and getting the last 3 hours or 2000 data points. As you can see, I only got an array of 360 data points back. So that means I'm capturing about 120 readings per hour, which kind of makes sense based on the frequency. So we're going to, open these, expand these. So these are just the raw values that we've recorded with date timestamps. So we should see they're all very consistent, right? So if I was to go look at my ML trends, I'm going to see there's really not much of a trend. It's very, very flat. Everything is 70. So very consistent. Here's my ML analysis engine that ran just pure JavaScript, no libraries. So my mean is pretty much the standard. Last value is 70. So it wrote all of these values back. This is what came out of the script. And I merge that into context. And then I'm going to upsert this baseline data. So I actually have a breakpoint here on the baseline data. So I can test this. You can see it's kind of has a dashed border around this node. And if I scroll down to debug, you'll see I have breakpoint here. So it does everything up to that point except for upserting that baseline data. So if I hit replay payload right here, it's going to take the input and move it through. So I'm not going to do that because I know it's already working, but that's essentially, and all of this was built with Claude, same process. It can, as I said, I can build this out with the nodes that I know that need to be here, or you can actually have Claude just build the whole entire thing, and you could export, for example, that flow. And here's the ML detection flow. Right? It doesn't look like much. It's just JSON, but this is the whole entire thing. So you could have this generated in Claude and then just import this, and it'll create the whole entire data flow diagram. I know many of our partners are doing this already. All right. So we can build screens, we can build flows, we can build documents, we can build integrations, we can build pretty much anything that we need to build very quickly. This whole entire application came together very quickly over the course of a couple weeks. Now, that might sound like a lot. You've probably heard people, oh, I vibe coded something over the weekend. And yeah, well, those are junk. Those are garbage applications that don't scale. You would never run a factory on them. I would have 100% confidence in this application being implemented at my factory. Why? Because it's built using the standardized building blocks that we have available within Fuuz. And I know that it's scalable because it's running in the platform, right? It's secure because it has to adhere to our role based access control policies. So I know all of those things just because it's in the Fuuz platform. Those are all of the things that you don't get with a typical, vibe coded application. And to build out an entire application, let's look at the application graph. So this is the whole app right here. So we have all of the purple are our data models like data point. We have all of these flows. We have all of these screens. This is an entire maintenance application, all with the UI as well. So if I go to my assets, kind of look at some of the other things that we generated with AI. This is my assets table. So if I go and select like that sub 250 work center, that's part of Enterprise C. I have my asset. It's linked to a work center. There's also a work center table. I expand this. I have all of the data points that belong to this asset. So all of that master data that we were querying, this is a good place where you could come and, edit the details of a data point or view the details, right? And I can change these limits. I can also come up here and I can add a new data point. I could duplicate the entire asset, creating a new data point and add that to the mix. Very easy to do. I can create a new asset here. So all of these forms, screens, tables, everything was done using Claude. But in Fuuz, again, so I know it's safe. I know there's permissions behind all of this. I don't need to worry about that kind of stuff. If I go to my work centers screen, we're going to see kind of a similar approach here. Again, also the other thing I want to point out here is consistency. My filters are on the left. My table is in the center. I've used this menu column for all of my actions. These are instructions that I provided Claude so that the application I'm building is consistent and people can actually use it. How many times have you built something with AI and said, "Hey, I need to make some changes." It makes some changes, and what it gives you is nothing like the first thing. It's not an iteration of the first thing; it's a complete redo. So I think that's really, really critical to take away from this is that using the building blocks in Fuse, you can build consistent user interface and structures and flows without having to go back every single time and start over. So we can do things like this OEE dashboard. This again was also created using the LLM and same kind of process. So charting library that we already have in Fuse, and everything is very nice, easy to use. Filter, I can turn things on and off. We have our work center historian down here. I've got all my loss analysis, my OEE per hour per shift for rolling 24 hours on this machine, my current mode and state, the last refresh. So this is going to look very similar to that alarms dashboard if we went behind the scenes. This one here actually uses what we call a web flow. So when the page loads, it triggers a flow that does all the calculations and then feeds them into the screen. So if I open this up, we'll see some of that. I'm going to turn this off. And if we go to context, this is far more impressive than the alarms dashboard. And we go to screen, context, just so you can kind of see what we're dealing with here. So At the screen level, my mini UNS, I have all the information about my work center, my schedule. So currently it's a second shift for this particular machine, the current state, how long I've been in this mode. So I've been in production, running slow for an hour and 22 minutes. I have all of my mode details, the state details, all of the metrics. So my current hour OEE. So I mean, this is incredible. This is everything that's available on this dashboard right now. Not all of this information is even being displayed on the screen, but what I was able to do with this web flow was do all of these calculations. They actually happen much quicker than in this recording because doing a screen recording typically slows down the way the screen renders. So all of these calculations happen in about a half a second and then load to the screen. Here's all the reliability, mean time between failure, mean time to repair, my baseline values, any trends, my efficiency, how am I running, my throughput, units per hour, my total runtime, good scrap, my loss analysis. The list goes on. Top downtime reasons for the shift. So all of this is what I like to call a mini UNS on the UI. Of course, this is always available in the backend. So I could publish all of this data anywhere, anytime in real time using Fuuz and a data flow. So the list goes on and on here of what we built, what we created for this. We have the reliability dashboard that's going to look at downtime trends and repairs and work orders and things like that for the past 30 to 90 days. We have the production HMI, which is a control panel. So this would be something you could put in front of an operator. So if you didn't have the machine integrated, this is going to show me the current work order that's in production, the product that's being made, my target quantity, what I've made so far, how close I am to completion. So based on everything, I have about 15 hours left on this particular work order before it should complete. The last time I recorded production, I made 23 good and 2 scrap. So I have a performance of 92.4. And that was, just a few minutes ago, someone recorded production. We have a little digital work instruction down here. So if you're thinking about, frontline worker application, you just want to do something simple, just solve one problem right now, real quick. This is an example of that. So, we'll do demos all the time. Some might say that screen is too much going on. My operators don't need all that. Operators don't really care about OEE. That's not really a good metric to track in real time. That's really something you should look at, tomorrow for the previous day. But we can hide, we can disable things. If I save that, do like that, and then I'm gonna come back and run that screen again. So, this is where you learn to use the screen designer. You can turn things on, turn things off. All that whole OEE section is now, it's not gone, it's just hidden. It's still there, but my operators don't need to see it. Right. So now I could run this screen on, maybe some type of a tablet, and I could put this out on the shop floor and I could immediately start collecting things like production, scrap, downtime, right? So now I'm running it on a tablet, and operators can click here, say they recorded 150 units. Maybe I want to track for some traceability, do some kind of a lot number, and component number is, a shim 123. And, we can submit that, recorded it, everything updates in real time. So just this was all, again, this is all part of this one application that we built out for ProveIt. We didn't get to show all of this, and there's much, much more. I could go on for a couple more hours, but I won't. But I wanted to tie the gap between how we're utilizing AI. It's not a it's not a magic bullet or a silver bullet. It doesn't do all the work for you. It still requires that you have somebody that has a pretty good idea of what they're doing. Now, I don't necessarily need to know what I'm doing in Fuuz, but I do need to know what my expectations are in terms of an HMI for an operator. I have to at least know what the desired output needs to look like and how it needs to perform and what it needs to do. So you can't just put somebody on building apps that has absolutely zero clue how the shop floor works, but this is definitely a huge time saver. So I would definitely say check it out. Go to our GitHub. Get yourself all of the skills, and we can actually go there, take a look at it right now. So I posted these projects, everything I just walked through. If you go to the ProveIt 2026 repo, you'll see there's a data broker, there's an enterprise B and an enterprise C. So you can download these Fuuz files. You can import these as in the Fuuz packages. Just go to the manual import. You can import them, and you can actually walk through everything I just showed you in your own environment. And then if you go back to the Fuuz skills repo, you'll have all of the skills you can download for building flows, schema, screens. There's some industrial knowledge in here too, like how OEE should be calculated, etc. This platform is like a main orchestrator. So when you're building an app, it helps the LLM understand like which skills need to be invoked at different times, right? So that's why they're all broken up this way. And then Fuse packages is what the LLM is going to use to help create a package. So that's basically a giant tar file with a .fuse extension, and then that's what you import into your environment. So if I go to, and this will be the last of this presentation, if I go to Fuse packages, manual installation, once you download those .fuse files, click here, and then you'll upload it. It'll take a few seconds. And as you can see here, it'll show up under installed packages. Now you can always uninstall. So if you do something you're not happy with or whatever the case is, just uninstall it, give it another shot. The other thing I would say is use those Fuse packages in your own LLM. You can ask it to generate documentation, end user work instructions, process flows for how the application works, troubleshooting. It'll go through all of the flows, all the scripts, all the screens, and it'll find areas. It's not 100%, but it's darn close to 80 to 85% accurate. It'll give you some great information, not only on our apps, but the ones that you build as well. So thanks for watching. Hopefully this was helpful and a good learning on how to create a workflow for yourself utilizing AI and Fuuz. If you're interested in signing up for Fuuz, we do have a trial that you can sign up for. I would recommend you go to support.fuuz.com, submit a ticket. We'll get you hooked up with a trial. We do have an MCP that you could set up as well, which would mitigate a lot of the manual copy and pasting that I was doing. But yeah, we'd be happy to have you try this out. And thanks for watching.